I think I need to redesign my weather stations and how I collect data from outside the house. And what I really need is a more reliable temperature measurement. Because I have a couple of ways how I measure temperature, but none of them really measure the exact outside temperature. So first of all, I have this Maplin weather station. And as you can see, it has temperature, humidity, it does wind speed, and it has a rain gauge. And so it does everything, but the thing is that obviously it has to be outside to measure temperature. But then this guy here heats up when the sun shines on it. So obviously in the midday I can't really use this for temperature measurement, because it's definitely going to measure more temperature than what the actual ambient temperature is. And then in the back of the garden I have another weather station which I built from scratch, and it's this one here. So this also measures temperature and humidity. It should have some ventilation through these vanes, and the other thing it has up here on the top, it has a light sensor, and I think it also has a UV sensor. And actually the only thing which I'm really using from this sensor is the light sensor, because that's controlling my blinds. It's covered in conformal coating and it seems to show some age, but it's still working fine. Oh, and you can see it like this. Yeah, I don't remember the exact type. Probably I'm going to leave it over the text. So this is a broken light bulb. So it covers, so it provides, well, obviously transparency for the sensors, and I don't think it actually blocks the UV. So again, out of this I only use the light sensor. So I think what I need is I leave the light sensor part of it and move the rest of it, which measures the temperature, move it in another place where it's going to be in the permanent shade. And I have one more thing, which is down here. As I get to the basement, I have this thing here. So this has an ESP VMOS Pro, I think, because this has an external antenna. And then it just has a couple of outlets which I control. And from here I also have two temperature sensors, which we used to run up to like a kiddie pool, which we are not using anymore. You can see one of the DHG temperature sensors. So I think what I'm going to use is I'm going to combine the weather station with this. So from here I'm going to keep the 4 relays, and then I'm also going to connect the light sensor to these, and then probably cable these two together. So the relays are going to be here, but the ESP with the I2C sensors are going to be outside. And I get rid of these temperature sensors because I don't really need them anymore. And on the northern part of my house I have this big tree. I think it's ash, but I'm not really sure. And what I was thinking that, oh, I have my main meters and my garbage bins and everything, so I have power here, so I can run power from here all the way to this tree. And I think I'm going to mount that weather station on this tree, maybe here, because that's pretty much in permanent shade. Well, even if I put it on the other side, then that's going to be north facing. So maybe I can put it here. So maybe it will get a little bit of sun in the summer when there are no leaves. Sorry, in the winter when there are no leaves. But other than that, this is like perfect position to measure temperature and humidity. So I think that's what I'm going to do. And I can run power to here through the bushes, and then back into the this shed. And then I bought this lampshade, which I usually use in the attic and in the basement, and it has a glass top. At least I think this is glass. Yeah, that sounds like glass. So I can remove this, and hopefully I can mount the the light sensor here, and maybe also the ESP. Maybe I'm going to reuse this shield just to protect the ESP from the UV. Well, maybe not this one because this is metallic, so that might block the Wi-Fi signal. And I was thinking that I'm going to mount this here at the end of the deck, so that pretty much receives sunlight every time, because by the time this tree started shaded, it's like sunset anyway. So I can have this here, and I can run a wire sort of like all the way back to that thingy which has the sockets, which is over there. And I'm thinking, well, at least I'm hoping that I would be able to run like an Ethernet cable, and this is sort of like, I don't know, 20 meters. So hopefully that's going to be enough voltage for the relay to still actuate back there. I have removed the case from this plug board. So this is the 4 sockets, and you can see that, you know, this generic Chinese relay board, and the ESP Pro Mini, sorry, VMOS Pro Mini, I think it's called, and it's a 5-volt power supply. It's directly plugged into the mains. And I think this was probably one of my first ESP projects. I think this runs a my own version of Arduino IDE code. And it's just basically 4 outputs, and it's reading these 2 temperature sensors. And that's it. So I should be able to gut this. I think I'm going to keep this guy for power, and I'm going to remove this, and yeah, definitely don't need the temperature sensors. And then the ESP is going to be on the lampshade on the other side, so I just need to run a couple of wires to get the power from here to the ESP and the signals back here to the relays. And that's how the new board is going to look like. So I don't think I've shown the inside of this before, so just the cable management. Okay, so there is this top piece which comes off to reveal the, well, cobwebs and spiders, and then that's the inside. And this whole assembly is on a removable 3D printed thing. Oh Jesus, this looks ugly. Man, look at this. I don't think I've shown this before. So this was completely open. So the end of the pipe was completely open. And by the way, if I show you the pipe, so this is just a PVC pipe that I drilled various holes, and I bought these. I think this is usually used collars to put it on, you know, when it touches the tiles, just to hide as the pipe enters the you know, the wall. And I have a couple of these, and there are holes drilled all the way through just to provide ventilation. And then the power comes through the pipe here, and the other side is open, so obviously critters could just move in, which they did. But as you can see, this is a roughly 2-year project, and within that 2 years it was running like this. And as you can see, AC, 240 volts AC coming through here. It gets rectified by this small power block, or reduced to 5 volts, and then it's running the whole show here. So that's spiders and everything. Yeah, I think I've conformal coated the ESP, so it, you know, is fairly decent. It looks very decent, but the whole construction is very, very simple, because everything is, well, almost everything is I2C. So we have one BMP280 here, so you can see 5 volt SDA SCL, that's connected to SDA SCL here, and then these 2 sensors are also on I2C. Yeah, so you can see the 5 cables here, and I also have these BMS PMS sensor that measures you know, particles, airborne particles, like PM 2.5, but I think this has pretty much died probably like 6 months after the installation. It sometimes still seems to, you know, sometimes kind of works, kind of doesn't. Sometimes it provides reading, sometimes it's not. I haven't implemented the code for this to put it into sleep, which is supposed to turn off the small fan, because ideally you want to, I think, bring it out from sleep. That spins up the fan, it, you know, cleans the air inside. You take a measurement and then you put it into sleep and then just sleep. So I haven't implemented that. So maybe this whole thing was running for, you know, months on end, and then probably just gave up. I have to test, maybe this is still working, but I'm not really using this. So only what I really need is the light and the infrared value from here, and then the temperature and the humidity, which is going to be on the tree. So I think I just have to duplicate this basic. No, I think I'm going to use this. Obviously I'm going to remove this sensor, and that's going to go back into the tube. This won't get removed. That moves to over here with another ESP, and basically I'm just going to cut this project in half. And you can see this 3D printed lattice is also starting to break apart, but hopefully it's going to survive another 5 years in the tube, where it's not going to be exposed to direct UV and the heat. Well, not so much heat at least. And yeah, also I'm not sure whether the operating temperature from the power supply, it has affected the BMP280. This is why I mounted it on the other side, but yeah, it seems to be working just fine. So this is temperature, humidity. Oh yeah, and it does air pressure as well, so I'm going to keep that. Okay, I think I need to talk through my neighbor cutting the front lawn, but I managed to unsolder some of the things. So this is where the ESP sits, and I disconnected the, so there was a cable here for the PMS 5003, that's the air quality sensor. So that was just power, and I think it was serial data. So I disconnected that, and I should be able to push this sensor out. So that was just a press fit into this cutout in the 3D printed skeleton. So I have the BMS, BME280, that's still connected. So you can see the I2C lines and the 3.3 volts for voltage. So at the moment, that's going to just run this. And the other lines here are also disconnected now. So these are also I2C and power. So I should be able to remove this sensor from this slot as well. It is just held on with a small screw, and for which I need a small screwdriver, something smaller than this. Ah, yeah. No, something bigger than this. So these bloody nylon screws have such a fat opening. Okay, and that's more or less press fit into the 3D printed hole. Okay, so this comes on, and that's the assembly for the two sensor. You can see it's straight wiring, nothing special. It was just a board to hold them in, and I think these are covered in conformal coating as well. This is why they look a little bit ugly. And I have this channel for the wires to go through, and yep. So this is free now. It's ready to be transplanted into the new device, into the new enclosure. And that's what's left of the skeleton. Okay, so I figured I can reuse my home sensor board that I did a long time ago, just to have a footprint for a bunch of sensors and a Vimos D1 Mini. And it also had a section here for the power supply, which I don't need, so I just cut that down, and it fits easily here. And I can use this pillar, which used to hold the lamp or the socket, and then the sensor can just sit in here, and I can wire this in, and that should be the new housing. Well, one thing I haven't checked is if I have enough clearance, which I think I may not have. Oh, no, I have plenty. Okay, so I think it's going to be something like this. I mean, of course, these ridges here in the glass is going to distort the light, but I'm not after some scientific, measurement. So if it can just, give me a very good indication of the daylight so I can control blinds and some other lights, that should be good enough. So I think it's time to solder the ESP on, and then I should quickly, well, I don't even have to put a new, well, it's going to run ESPHome, but I don't even need a new ESPHome instance because I pretty much have the ESPHome sketch or the YAML file for the old project. I just need to remove the sensors that I don't have anymore. And apply some flux, and I'm going to use my TS100 soldering iron, which the screen has long gone, so I'm just operating by feel. And actually I ordered a replacement screen, I just haven't bothered to change it, so I think maybe I should do it at some point. I don't think I'm going to change this soldering iron because it just works so great. I mean, there is a new version which can run on USB-C as well. And actually, I'm thinking that I'm going to power it from USB-C. So I bought some of these USB-C trigger boards, and I have a big power supply now. And that can deliver 20 volts, 5 amps, which is more than what this soldering iron can use. Well, it can go all the way up to 24 volts. But at the moment it is also I'm also using 19.5 volts. I have a big GBL speaker, and it came with a big sort of like 19.5 volt charger brick, just like a laptop brick. And I'm using that to operate the soldering iron. Good that I'm not in my room because these things are flying all over the place. But actually this is my workshop in the garage, so I don't really care. Okay, that's done. ESP is seated. But this footprint, 3.3 volts ground, SCL, SDA, and SDD and CS for something else. So I think I'm going to use this. I mean, this footprint is really messy. I mean, not the footprint, but all the different sales screen and everything, because I didn't want to have the footprint for the space for all of them, so it's like all of these just on top of each other. Okay, I need a little bit of solder. So I think it's time to put the firmware together and see if this actually works. No reason why it shouldn't, but... Just a really quick word on the code, which is running on the two weather stations. So this is the temperature station. So that's one which has the BME 280, and then this also going to have 4 relays, because I just have a relay board, and why not? And I just took one of my previous ESP Home YAML files. There's nothing really special about that. It's pretty much the same as what I have done for pretty much everything. So I have a secrets file where I'm going to store all my password and stuff. And yeah, so I configured the I2C for the BME 280. So it's pin 4 and 5, and then I have this human readable text which is going to give me just 1 second. Yeah, because that's how the UI looks like. So that gives me this human readable uptime if I need to display it anywhere. And I defined all the switches. So they are just platform GPIO, and then I have relay 1, 2, 3, 4, and they are pin 14, 12, 13, and 16. So which are actually, I think I have a diagram here. So it's so 14, 12, 15, and 16. So D7, D6, D5, and D0. So D5, D6, D7, D0, right? D5, D6, D7, D0, 14, 12, 13, 16, 14, 12, 13, 16. Yeah, that's how I connected them. And I have one which is reporting the RSSI, and that's the BME280. And I think, again, this has changed because previously it was just a platform BME280, but now it's BME280 underscore I2C. I think there is probably an SPI variant as well. And I had to set the address to 76. I'm not sure which one is the default. And then it just gives me free measurements. So temperature, pressure, and humidity in separate topics. So I specify the state topic manually instead of just relying on that to be auto-determined. And the rest of it is uptime calculation, and I enable the web server. And that's what you see here. So I think I'm not going to use it a lot, but it is also quite useful. I can do OTA from here as well, and I can operate the relays from here if I need to. So it's good to have this website. I always include, and you need only these couple of lines. And I wanted to do the light station as well, which has the UV sensor. And I think I was playing around with this a lot, like 2 years ago, maybe 3 years ago when I started this, because the only way to include these SI1154 and VEML 6070 sensors is just to provide these includes in libraries. I think I've took the example from somewhere, and the rest of it is is the same. So I2C, and that's how you define the UV sensor. So it needs a couple of functions, lambda functions, in order to calculate and then get the values. And also pretty much the same for the SI1145. And I just couldn't compile it. I was getting errors all the time, and I couldn't really figure out why it is not working. And I wasn't really sure if I could get it working last time, but I started to dig around in my Arduino IDE sketches, and I actually found one which was called the weather station. And so I made a quick copy of it, and I just stripped everything except the VEML 6070 and the SI1145 sensor code, and then just removed everything else. So that was related to the BME280 and the dust particle sensor. And I also added the code for the D5, D6, D7, and the D0 for the output relays. So here on the top I have a lot of decoration for the various topics, and I use the same concept that I used in the old ESP, which was running the original 4 relays. And so I had a separate topic for the relay status, and I had a separate topic for a set. I guess it's not the best, or it's not the most elegant. I think it makes more sense these to have like the base topic for status, and then you have a /set or something else. But anyway, that's how I used in the past. And the code is, so it only has the code for these 2 sensors and the relays, and there isn't much to it. I have a set relay function that I can call based on whether it's whether I receive an update over MQTT or even HTTP. And so I'm setting the 4 relays based on what is the relay ID and what's the state. And there is a status update here. There is a timer callback functions for a timer. So every 10 seconds it reads the sensors and refreshes the topic, and it subscribes to all of its topic, so it can listen on the relay set topics or messages. And again, here in the callback so that's the callback for the MQTT, whenever MQTT message is received. And as you can see, message arrived, and then we are checking whether it's the relay 1 topic, the relay 2 topic, 3, and then I call the set relay message. So I expect the payload to be either 0 or 1 for on and off. And I also have a handler relay command, and that's will listen on the /relay URL. So you can change the relays using HTTP as well. You can see it's looking for parameters, so it has a relay and a state parameter.
which again, relay could be 1 to 4 and the state would be 0 and 1. And yeah, and in the setup, I just set the default outputs for the various relays, and I set them to high because all these relay boards are on active low. And I wasn't sure if I can use the first relay, which is GPIO 0, and this one, sorry, GPIO 16, which is D0, but it says that high at boot. So that's actually good for me because my default state should be high. And that's not going to keep the ESP from booting. And yeah, there's nothing much really here. I mean, I set up the, the HTTP responder and, the timers and connect to the MQTT server. I initialize the 2 sensors, and in the main loop, I just handle the server event. So I don't have this guy up and running, so I can't show the web page. It's a very simple web page. And I handle the MQTT reconnect, and I calculate uptime. And this is how you read the various UV sensors. So you can see it's, yeah. And whenever I read it, I publish the value onto the MQTT topics. Yep. So you have a UV index, sorry, a UVI value. So this is the raw UV value. And then you calculate the UV index by dividing it by 187. That's what the documentation said. And I think the UV index usually goes from 0 to 9, right? But with this calculation, I'm getting UV indexes of like 11. So that's not really useful, I think. And then you have the light sensor, infrared and the actual light. And I can't remember which one I used to control my blinds. So this is going to be up on GitHub, and also this, where is it? Yeah, so this temperature station YAML file is also going to be on GitHub. So if you want to replicate the whole project, then it should be fairly easy to do.
I continue some of the build off camera, and I think this is how this is going to look like. So this is just a protective plate, just to, well, basically protect the ESP from the UV radiation. Yeah, I guess it wouldn't hurt just to have an extra layer of protection, physical protection. And what I have done, again off camera, you see this purple wire. So this is a network cable. And so I used 6 of the 8 cores in the network cable. So I have, I think, 2 cores soldered to, I found a +5 and a ground here. So I created that for one of the sensors. So that's going to give power from the main box, which has the 5-volt power supply. And then I used 4 connections here. So I had all of the unused connection routed out here on this PCB. And so that's D5, D6, D7, and D0 of the ESP. So that's going to control the 4 relays. And I've tested it, and it works. And, these pins are safe to be used as outputs. They don't stop the ESP from booting. And of course, previously I soldered the 3.3 volts SDA ground, SDA and SCL, and that goes through here. And actually, I don't know if it's going to be visible on the camera, but you can see the markings here. So V in ground, SCL, SDA, and these pins are parallel between these two modules. So they are working. And yeah, and so I have the cable which is running down, and I also added a cable, not a cable type, but this sleeve here, because this first part is going to be out on the sun. So I wanted to give an extra protection, and the rest of it is going to be inside. So it's not going to get protected, or sorry, well, it doesn't need to be protected, at least from UV. So this is just a bent piece of plastic, which sort of like press fits here. And I realized one issue with my design. So I think this light was obviously designed to be mounted on a wall, which means that there is no rubber gasket over the glass, because it was always designed that the water is going to run down that way. So now, because it's going to be mounted face up,
it means that water is going to pool here. So, and it's going to be mounted at a slight angle like this. So I cut 2 notches here. So I'm hoping that whatever rain that sort of goes above the shell and starts going around this groove can exit here, and it will not go into the inside. But of course, I have no idea. So that needs to be tested just to make sure this whole thing is watertight. Unfortunately, it is so easy to get this top off because I just lift these 2 things up and that's how it's secured. So maybe I can install a gasket under it, but it is like a fairly solid press fit already. So this wire might cast a shadow from time to time, but yeah, I guess I can live with that. Okay, so a couple of days have passed and I did a few things here. So that's going to be for the temperature sensor, which is going to be next to the tree. And I created this. And so that is a 4 channel relay board. And so I'm going to have some powered sockets at the tree because I have 2 rules. So rule number 1 is never pass a chance to have some extra power sockets in a smart home. And the rule number 2, if you have some free pins on an ESP, you might as well just use it. So I'm using the extra pins to drive some relays. And I've also updated the firmware for the temperature sensor. So this one is now running the ESP Home firmware, and I have the wires wired for the 4 relays. And the power brick is removed from here because that's going to be in the box, and the BME is still there. And 2 days ago I found a skip because there is a construction going on in that road, probably about 100 meters from here. And I've noticed that they had a skip for all the construction scrap, and they threw out perfectly good wires. So I went back in the evening and I nicked it. And this is a bunch of single core 1.5 square millimeter wires. I think there is a bunch here which is slightly thicker, but it's really good for road projects. So even this guy is made from these leftover cables. So part of this project was absolutely free. And I've also gone to the hardware store and I created this coupling. Well, I bought this coupling and a cup so I can close the top of this station, because now it's only going to mount the temperature and the humidity sensor. Well, that's just going to poke through there and it's going to breathe, and I don't need the top dome anymore. So that's going to be nice. And by the way, oops, probably by the time this video airs you have seen the Napcat camera. So that's sitting here, partially surrounded by cobwebs. And now we can head down to the dungeon to finish the installation of the light sensor. So that guy's going to be here, and let me do the wiring. So I had some box here for some old project and a couple of wires, so I removed that. I removed the old the temperature sensors. So now it is a much cleaner area. And yeah, so I'm just going to gut out the ESP and sort of rewire the connections, and this project should pretty much be ready. Okay, Houston, we have success. So you can see the cable coming in, and then so that's the connector for the power, so the brown ones. So that goes to power, which I took off from the old temperature sensor output.
And the other 4 cables, I'm not sure how much is going to be visible, that goes to the relay board. And well, either you can see or not, but I got update on, let's say, the UV 2 seconds ago, light 4 seconds ago, 5 seconds, 6, 7, 8, 9, and restart. Yeah, so that's first of the objective is done. The other one was I wasn't sure if the relay is going to be working, because then the 5 volt goes from here all the way to the ESP, and then the signal comes back, which is already only 3.3 volts, I think, the output on the ESP. But this is a 5 volt relay, but which I know works on 3.3 volts, but I wasn't sure if it can tolerate any more voltage drop. But if I turn on relay 1, it turns on, and then relay 2 and 3 and 4. The delay is because my phone is getting very weak Wi-Fi reception. But it is working. The order is all over the place, so I think 1 is 3 and 2 is 4, but anyway, I'm just going to relabel the sockets, and that's going to be it. So this guy is going to be on the ground, well, just above the ground. So I need some sort of post that I can drive into the ground, and this can sit on that post. So let's look at some scrap metal. Okay, so this is my dungeon. And I think from the last project I have these 60 by 30. Ugh. I mean, it is a good piece of box section. Probably a little bit overkill for this, but I don't think I'm going to use this for anything else. So otherwise it's just going to sit here. So I might as well use it for this project. It is about 1.5 meters. I need to cut this, make it into a T, and I still have plenty of space to drive it into the ground just to make it stable. I think that's going to work. I should work a little bit faster. That's not nice, but it's going to do. That's much better. That's it.
So this hell of a project is coming along. I'm saying hell of a project because I'm digging trenches here and, you know, on my knees in the dirt, and it's bloody April and we already have mosquitoes. Maybe these are the type that are not biting, but still mosquitoes. And I was trying to get this into the ground, this T-post, and well, I mean, it's right next to the tree, so there was like branches and roots and everything, and I actually had to dig it out by hand, but it's fairly solid. I don't know how much is in the ground, probably like 40 centimeters, not much, but it feels solid, so I'm happy. So this is the thingy which goes to the temperature sensor, and we have the orange one which is power. And I know this orange one is not how do you call it, UV stabilized, but it's not going to get too much UV here. And I pretty much have the wiring done already, so it's same as the other project. So I have a network cable coming up, and I have the small 5-volt power supply here. It's just like, you know, hanging therein, flapping in the breeze. So 5-volt goes to the relay board, and also 5-volt goes to the ESP. And yeah, so I need to just connect power here, but I need to finish digging. So I only dig like a 2-inch deep trench, something like that. I can't be bothered to do anymore. You can see it here. Like, I have to fight with these bushes. Oh man, I had enough. With this, I need a beer or two. Yesterday evening I finished the installation of camera. I mean, this is all bolted and closed up, and the power is connected. I think what I need to do is I need to make some sort of cover for this one, because these are IP65 rated, which is good, but I think once I plug something in, that it will be more exposed. So I think it would be good to create some sort of like cover, something like I don't know. I have some aluminium, so probably I can just bend something a really simple shape, but that has to be done another day. And also the cable here is a little bit up in the air, so probably I don't have an appropriate bracket, but I think I'm probably just going to bracket it to the tree. And the sensor is here. So I got this pipe clamp, and it's drilled into the tree, and that's the sensor. So that's the sort of the coupler and the top, just to close it off, and everything is inside. So that looks good. And that's how it looks from the other side. And this is the northern side of the tree, so it will not get any sunlight. So yesterday I also modified the Node-RED flow in order to collect the data from the new sensors, and I noticed that the BME 280 is showing about like 2 degrees extra from, you know, what I measure from my other sensors. For example, the Maplin weather station, which I consider the gold standard. And then I started looking online, and I found this article somewhere which actually referenced the original Bosch BME 280 datasheet, which says that the temperature sensor is only created to provide an approximate temperature measurement, which is used in order to compensate for the humidity and the pressure reading. So basically the only thing which I really wanted to use from this weather station is inaccurate. So what I did now is in Node-RED, I calculated about 2.1 degrees from the measurement of the BME 280, and I'm just going to graph it compared to the Maplin weather station. So I'm hoping that if this drift is a fixed value, then I can just subtract it. But if this drift changes, and then I guess I need to put another temperature sensor into this unit, because well, that temperature has to be a good temperature. Yeah, so this is an awkward development. Maybe I should have done that research beforehand. Or maybe I'm thinking, maybe I'm going to check if the BME 680 is better for temperature measurement, because it would be easy to swap out this the I2C sensor with another I2C sensor, although I don't have a spare BME 680. I think I don't. So that's it. I think probably we can do some after project actions. I wanted to do this on time because the weather turns bad next week and there's going to be a lot of rain and muck, so it will be difficult to work outside. So I think we managed to complete this on time, definitely on budget, because I hardly had to buy anything. I had to buy the new enclosure and one of these sockets, and I managed to reuse some old wires from the old project. And as I said, I managed to get some wires from a skip in the construction nearby. So actually I have some extra wires. So in terms of this cost is, that's check. Sustainability is check, because I managed to get most of the stuff done. And now the only thing which is left is to modify the flow, especially the irrigation flow, so I can input the temperature data into that logic. And this is why the temperature was important. So I think that will be next what I will be doing, maybe in a few weeks. But I think I'm going to close this video. So that was all for today. Thanks for watching, and hopefully see you next video.